Introducing the 300 kilonewton computerized electromechanical universal testing machine. The system features advanced hydraulic wedge grips. Inside, you will see a metal rebar sample. The hand controller on the right operates the upper and lower grips. The hand controller on the left moves the upper beam up and down. This is the computer control system. The unit's power supply is 220 volts, 3-phase, 50-60 hertz. This is the hydraulic power pack with touchscreen operation. It presets the testing pressure and controls the upper and lower clamping of the hydraulic grips. The hydraulic operating unit is designed with user-friendliness in mind. This 300 kilonewton universal testing machine is equipped with an alignment device precisely calibrated to meet NADCAP certification standards, making it an excellent long-term asset for manufacturing facilities, laboratories, and other testing environments. This is the power pack. It requires 80 liters of new hydraulic oil, ISO AG46. This is the hydraulic pump marked with numbers 1, 2, 3, and 4, which can be connected to hydraulic grips. The power supply is 3-phase, 220 volts. This is the back of the computer. Connect these cables to the hand control box. The white cable is the data communication cable, which should be connected to the testing machine. Additionally, this is the load cell cable, while this is the extensometer cable labeled 3575 for one extensometer, and this one is labeled 3542 for the other clip-on extensometer. The mainframe power is 3-phase, 220 volts, 50-60 hertz. This is the power cable, and here is the communication cable. This cable is for the 300 kilonewton load cell. Before dispatch, the bolts at the top were firmly tightened to maintain proper machine alignment. Do not unscrew these bolts, as doing so will cause misalignment and prevent the machine from passing NADCAP certification. For alignment adjustments, use the bolts on the alignment device directly. These are the tensile jaws. The interior surfaces are smooth, which facilitates precise alignment adjustment. When performing your alignment certification, you can conveniently clamp your device in these jaws, which are marked from 1 through 4. This is the power pack. To start the operation, press Pump On, click Start. You can preset the pressure target and the clamping pressure target by entering your preferred value, for example, 10 megapascals. Then click Enter. The current target is 15 megapascals. The protection pressure is set at 25 megapascals. Here you can see the hydraulic oil temperature. An alarm will sound and the system will automatically stop when the temperature reaches 50 degrees Celsius. These 4 buttons control the upper and lower clamp and release functions. First, press upper clamping. The pressure will reach 15 megapascals as indicated by your target. Then press lower clamping. The system will too reach its set target pressure. Then click lower release. And finally click upper release. When using the manual hand control box to clamp and loosen, press a button, for example, upper clamp, and monitor the system pressure. Once the pressure reaches 2 megapascals, release the button. The grips will gradually move toward the indicated target pressure. The same procedure applies to the lower operation. Hold the button until the pressure reaches 2 megapascals. Once this level is reached, you can release the button and the system will continue to attain the target clamping pressure. First, press and hold the upper clamp button. When the pressure exceeds 2 megapascals, release the button. Then press the down clamp button. Once the clamping pressure reaches 15 megapascals, you can press down loosen and finally press upper loosen. The rebar pull test. Once the test is finished, remove the extensometer. Continue the rebar pull test. Now we can perform a test on a tensile specimen using both the clip-on extensometer and the transverse extensometers. Wait for the test to finish. Once completed, you can obtain an accurate data report. Tensile test by a clip-on extensometer. First, select a test standard, in this case ASTM E8. Then click New to input the sample information. The sample type for round specimens is indicated as circle. The flat specimens are indicated as flat. When selecting your specimen type, be sure to include the diameter details for round specimens and the thickness details for flat specimens. The SO section refers to the cross-sectional area and will be calculated automatically, while LO stands for the gauge length. Click on the Input a Batch of Specimens tab to open the Batch Add window. For example, we can choose to test 3 samples. Click OK. We will test one by one. Close the data pad. The extensometer display mode should be selected in gray color. The test should indicate 0 extension and 0 displacement. For the control mode, you can choose from tabs including displacement control, load control, extension, tensile program. Typically, we start with displacement control, then select the speed, for example, 10 millimeters per minute, and click Start Test. When the red notification comes on, please remove the extensometer. After the sample breaks, the software automatically stops. You can click on the Data tab to check the test results. The maximum force is 156 kilonewtons. RM refers to tensile strength, while FEH refers to the upper yield load force. We can also check the load extension curve. Recherche refers to the upper yield load strength, while REL refers to the lower yield strength. FP stands for proof force, and RP stands for proof strength. You can also see the total force, total strength, and modulus of elasticity. All points are conveniently indicated on the plotted graph. Click Print to review the test report for the load extension curve. You can click Edit to choose other curves, such as stress-strain curves. Once you have selected your preferred curve, click Save, and then click Preview, click Setting, and select an option from the drop-down menu. You may choose a proof strength setting, such as 0.1% or 0.2%. The P1 and P2 positions can also be adjusted. After making the changes, click Analyze Test Curve, and the RP value will change. Here are the steps for calibrating the transverse extensometer. The gauge length is 25 millimeters, and the travel is 12.5 millimeters. This is a standard extensometer calibrator. First, we will clamp the extensometer onto the calibrator and loosen the pin. Then we will adjust the device to either 5 millimeters or 10 millimeters. At a later time, we will begin the calibration from 0 millimeters. Calibrate to 0.5 millimeters and click Add in the software. 1 millimeter, 1.5 millimeter, 2 millimeters, 2.5 millimeters. After adding all of the points, click Apply and click OK. In the software, you will see a window for the transverse extensometer. Right-click the window and select Channel A Calibration. Here you will see that calibrations have been conducted for 0 millimeters, 1 millimeter, and 2.5 millimeters, each with its corresponding sampling value. When calibrating for the first time, you may delete all existing values, input 0 in the calibration value field, and click Add. For the first point, we will calibrate at 1 millimeter. Now that it is at 1 millimeter, click Add, and we will move to the next point, 2.5 millimeters. At 2.5 millimeters, click Add, then click Apply, and finally click OK. After that, we can check for accuracy. 1 millimeter, 0.5 millimeters, 0 millimeters. This completes the calibration procedure.